Okay, so in 2.7, what we've talked about so far, when you have a division with polynomials, you've got a dividend, you divide that by a number that's called the divisor, you get a quotient, and you get a remainder over the divisor, okay? Well, if we write this as polynomials, f of x is divided by d of x. I get some polynomial q of x, my quotient, I get a remainder divided by the divisor. Now, what happens in the case that the remainder is 0? And that's a typo, it says reminder. So if the remainder is 0, then this whole term goes away. So I get, when I divide these two, I get a quotient, okay? So that means that I can write this polynomial as the product of which two. If f of x over d of x is equal to q of x, then f of x is equal to what two things multiplied? D and q. Okay, so think about it. When 35 divided by 5, you get what? 7. So 35 is what times what? 5 times 7. So anytime you get a 0 remainder, it means you have found a what? You have found a factor. Okay, so in actuality, you found two factors. So again, so like if I had something like when, so 35, let's just do 35 over 7 is 5. That means that 7 and 5 are factors. Okay, so anytime I get a 0 remainder, I have found two factors of the original. Okay, so what we're going to do is start working with synthetic division, continue like we've been doing, but our whole goal is to use synthetic division now to help us factor polynomials. So let's take a look at an example. So I give you a polynomial here. What is the degree of this polynomial? Yeah, it's a third degree polynomial. And I tell you that one factor is x minus 3. So if x minus 3 is a factor, what happens when I divide this polynomial by x minus 3? I get a remainder of 0, okay? And after I get a remainder of 0, that means I found what? What I have found. When the remainder is 0, you found a factor, okay? So if x minus 3 is a factor, how do I set up the synthetic division? What goes on the outside? What number? Where do you get the 2 from, huh? If x minus 3 is a factor, I'm going to write synthetic division this way, okay? And now some people made mistakes here. You got to figure out how to do this. If I'm dividing into a cubic, that means I must have an x cubed, an x squared, an x, and a constant. I have to have numbers in all 4 of those places. If one of those is missing, what do I put there? 0. You got to know that, okay? So what are the coefficients? The coefficients here are 2, negative 11, 3, and 36, okay? If I bring the 2 down, what's 2 times 3? 6. Add those numbers to get negative 5. 3 times negative 5 is negative 15. Add those numbers to get negative 12. 3 times negative 12 is what? Negative 36. I get a 0. Okay. If you're ever working this problem and I told you x minus 3 is a factor and you don't get a 0, one of us made a mistake. Either I gave you bad information or you made a mistake. So if I ever see a problem like this, if you ever see it and I give you a factor, you have to get a 0 there. So if you don't, like I said, one of us has made a mistake in this problem. Now, what does this mean? How do I read this? This is x cubed. This is 2 what? Yeah, this is x squared, x, and constant. So now what I have is 2x cubed minus 11x squared plus 3x plus 36. What are the two factors that I know at this point? Well, one of the factors is right here, x minus 3. What's the other factor? 2x squared. Yeah. Minus 5x minus 12. Okay. Now I'm after solving this. So to solve it, I have to get it factored completely and then set each factor equal to 0. Is this right side, is this factored completely? No, because I have a quadratic that I need to see if that quadratic can factor. And that's something we did in semester 1. So if that factors, I need to find two numbers that multiply to give me negative 24 and add to give me a negative 5. So what numbers will do that for me? Yeah, negative 8 and positive 3. Those numbers multiply to negative 24, add to negative 5. So I can rewrite, so 2x squared minus 5x minus 12, I'll rewrite it as 2x squared minus 8x plus 3x and minus 12. And then I factor out what do these first two have in common? 2x, x minus 4, plus what do the others have in common? 3 times x minus 4. So what's this final factorization? Yeah, this is 2x plus 3 times x minus 4. Okay, so the complete factorization. So I started out with what? 2x cubed minus 11x squared plus 3x plus 36. What is the complete factorization now? Yeah, x minus 3, that was my first factor. Yeah, 2x plus 3 and x minus 4. Okay, that is my complete factorization. Now, how do I find the solutions? I set them equal to what? 0. So my final solution is what numbers? Yeah, 3. Yeah, negative 3 halves and 4. Okay? So really, there's nothing new here. We know how to do synthetic division. We know how to factor a quadratic. We had to put both of those skills into play one after another to factor this cubic. Okay? Now, if you had seen this on the previous quiz that you just took, you would have looked at this cubic, you would have said it's 4 terms, and you would have done what? Factor by grouping, okay? So I would have given you something that factors by grouping. Not every polynomial can factor by grouping, okay? If I tried factoring by grouping, this would be x squared, 2x minus 11, and that's 3 times x plus 12. This does not factor by grouping. So not everything that has 4 terms will factor by grouping. This one will not. So the way you do that is you're going to have to use synthetic division to get down to a quadratic, and then your skills of factoring quadratics will work, okay? You should be very comfortable when I tell you, x minus a is a factor. That means that x equal a is a root or a solution or 0. So be very comfortable switching back and forth between those terminologies, okay? So let's look at another one. Factor this completely. So factor f of x completely given that g of x is a factor. So I start out with a cubic. So I would do first synthetic division. When I do synthetic division on a cubic, I will end up with a what? A what? No, I don't want to get a remainder, but I want to get what degree? If I start with a cubic, I'll get to a quadratic, okay? So if I start out, let's divide this by x minus 4. So x equal 4 goes on the outside of the synthetic division. So this is 4. And if you must do this, go ahead to keep it straight. This is a cubic. I must have an x cubed, an x squared, an x, and a constant. I have to have each of those filled in. Okay? So what's the coefficient of x cubed? 2 of x squared. Negative 11, and then 10, and 8. So the 2 comes down. What is 2 times 4? 8. What's negative 11 plus 8? That's negative 3. 4 times negative 3 is negative 12. Okay. 4 times negative 2 is negative 8. 0 remainder. That means that x minus 4 is a factor, which is what we were told to begin with. So now let's write, so this corresponds to my, what term is this? This is my x squared, that's my x, that's my constant, and that's my remainder. So f of x, what are its factors now? X minus 4, that's one factor. And then what are the other what's the other factor? Yeah, 2x squared minus 3x minus 2, okay? I'm not completely factor because now I need to factor which one of these? The quadratic. So we know how to do that. So in order to do that, I'm looking for two numbers that multiply to what? Yeah, negative 4 and add to negative 3. What numbers will do that? Yeah, so negative 4, positive 1. So I'm going to write this as 2x squared minus 4x plus x minus 2. And what can I factor from the first two terms? Yeah, so 2x, that leaves me with x minus 2 plus x minus 2. So what is that factorization? 2x plus 1, yeah, times x minus 2. So my complete factorization of this guy, f of x, is what? What are all the factors now? Yeah, x minus 4 times 2x minus 1, x minus 2. That is the complete factorization. What if I had asked you for all the solutions or roots? 4, 1/2, and 2 would be the solutions. Okay, so I can ask this question in a couple ways. Find all the roots, find all the solutions, find all the zeros. Those all mean the same thing. Complete factorization is this, okay? To find all the solutions, you have to go through the factors. You have to find all the factors first to find all the solutions. Was there a question? Oh, that's a mistake. That's 2x plus 1. Thank you for finding that. Why don't I make that a little bit clearer? So 2x plus 1, 2x plus 1. So the solutions are 4, negative 1/2, and 2. Okay? Okay? So again, these start to have a rhythm and a pattern to them. I'm starting out with a cubic. When I divide it by x minus 10, I'll end up with a what? What will I end up with after one synthetic division? The cubic becomes a what? Quadratic, okay, which I factor. So if x equal 10 is a 0, what goes on the outside of the synthetic division? What number? 10, okay? This means that x minus 10 is a factor, okay? So you need to be very comfortable with x minus 10 is a factor, x equal 10 is a solution or root or 0, okay? So outside the synthetic division is the number 10, and then I need something for the cubic, the squared, the linear term, and the constant. So all of those must have a coefficient. So the coefficient of x cubed is 4, and then I get negative 25, negative 154, and 40. So the 4 comes down. What is 4 times 10? 40. What is 40 minus 25? 15. What is 10 times 15? Yeah, 150. What's negative 154 plus 150? Negative 4. What's 10 times negative 4? Negative 40, and that is 0. Okay, so that means that x minus 10 is a factor. We already knew that. So f of x is, what are the factors right now that I know? What's the first factor that I know? X minus 10, and then how do I read that bottom line? Yeah, 4x squared plus 15x minus 4. Now to get this completely factored, I need to factor the 4x squared plus 15x minus 4. So when I look at that, I'm looking for two numbers that multiply to give me what? Negative 16 and add to give me 15. What numbers do that?
Oh, 16 is -1.
Yeah, so 16 and -1, those multiply to negative 16 and those add to 15. So this is 4x squared plus 16x minus 4. I can factor out a 4x, and then this is what? X plus 4 minus x plus 4. So this is what? 4x minus 1 times x plus 4. So the final factorization is f of x is x minus 10, 4x minus 1, x plus 4. So that's the factorization. What did they ask me? Find all the zeros, okay? They gave me x equal 10 as a 0, so I always just tend to write them all down. It's 10, and what else? 10, 1/4, and negative 4. Those are all the roots or solutions to that polynomial. Okay, fairly straightforward, right? I mean, why don't you guys work the next one, okay? So the next one you can work on your own, and then we'll group back and see what we get. In this one, what did you get for, when you did the first synthetic division, you end up with what? X plus 2 times what? What's your quadratic? Minus 19x minus 4, was that it? Okay. And then you needed numbers that multiply to negative 20, add to negative 19. That does work. So you got your f of x. What was your final factorization? 5x plus 1 and what? X minus 4. Okay. And so all of the zeros would be x is equal to what? Negative 2, what? Negative 1/5, and 4. Those are all the roots or zeros to that. Okay? So let's do one more. I think you've got some space, or let's do one more, and then we'll call it a day and you can start on the homework. What's different about this one? Yeah, first of all, it's a what degree polynomial? 4th degree, and I gave you how many factors? So if I give you 2 factors of a 4th degree, once I do 2 divisions, I'll end up with a what? I start with a 4th degree. Yeah, well, after 1 division, I get a cube. After another division, I get what? Quadratic. So I still have enough divisions to get me down to a quadratic. So let's set this up. So do you have your choice which one you want to start with? 7. Okay, so that means a negative 7 goes on the outside. Okay, it is not. So I'm going to need an x to the 4th, an x cubed, an x squared, an x, and a constant. Okay, so that means I've got what? 6, 19, negative 166, negative 31, 28. Okay, so what's the first step? The 6 comes down. What is negative 7 times 6? Negative 42. And then 42 minus 19 is what? Is that 13? Oh no, 23, right? Is that right? Well, you'll have a calculator. So what was it again? It was what? 42 minus 19. So 42 minus 19 is 23. Okay. Then I need to figure out what is negative 7 times 23. So 7 times 23, 161. So this is negative. Wait, this one is negative. Okay. You see I'm making mistakes. That one is positive. Okay. So what is negative 166 plus 161? Negative 5. What's negative 7 times negative 5? 35. What's 35 minus 31? 4. What's negative 7 times 4? Negative 28 and 0. Now, the mistake that I made a minute ago, if I'd have kept on with that mistake, what number would I have gotten? That looks like a little Valentine heart there, doesn't it, for the 0. Let's take care of that. What would have happened if I had made the mistake and kept on and didn't find it? At the end, I get a number that's what? Not 0. Okay. In this problem, that means either you or I made a mistake, because I was expecting to plug in negative 7 and get a 0 remainder. Okay. So this is what? 6x cubed minus 23x squared minus 5x plus 4. I need to do synthetic division again with what number? 4. So I will just do this. Okay. And let's just do it again. So bring the 6 down. What's 6 times 4? 24. 24 minus 23 is 1. What is 1 times 4? That is 4. What's 1 times negative 4? Okay. And I'm done. Now, this is my x cubed term. This is my what? X squared, x constant, and my remainder. Okay? So now I know that this polynomial f of x, what are the factors? What are the two that we know? Yeah, x plus 7, x minus 4, and what's the one that we have down there? What's that one? Yeah, 6x squared plus x minus 1. So now what do I have to factor? I've got to factor 6x squared plus x minus 1. So 6x squared plus x minus 1, I'm looking for two numbers that multiply to negative 6 and add to 1. What numbers multiply to negative 6 and add to 1? Yeah, so it's 3 and negative 2. Okay, so this is 6x squared plus 3x minus 2x minus 1. And then I can factor a 3x out of the first term. So this is what? 3x minus 1. 2x plus 1. That's from factoring the quadratic. So my final factorization is what? F of x equal x plus 7, x minus 4. And then what do I have? 3x minus 1, 2x plus 1. Okay. So there's nothing really new today. It's synthetic division and factoring quadratics. It's just we put them together with harder problems that take more what? Time. Okay. So when you look at a fourth degree like this, 1, 2, 3, 4, 5 terms, you don't have a method for this. Okay. You don't have factor by grouping. There's no difference of squares. There's no greatest common factor. None of the other tricks we've learned so far work. So if I can figure out enough factors to get it down to a quadratic, then I can solve the quadratic. What was the aha moment there, Kyle?
I just actually know it.
Okay. Yeah, so in this one, I did 2 successive synthetic divisions. I started with a 4th degree that left me with this quadratic. You should be able to factor quadratics, okay? Okay, so you've got time to take a look at the homework, and then we will pick up there when I see you guys tomorrow.